In this video, I want to look at the complex roots of polynomial equations with real coefficients. A polynomial equation is something like 3x cubed minus 2x squared plus 7x plus 1 is 0. In other words, all the powers of x are positive whole numbers or 0. We saw in an earlier video that if we have a quadratic equation with no real roots, the two complex roots form a complex conjugate pair. Just remind you of that with an example. If we take x squared, whoops, what happened to all that? If we take x squared minus 6x plus 34 is equal to 0, we can complete the square. X squared minus 6x plus 9. That leaves us with 25. Conveniently, 25 is a nice number. The first bit gives us x minus 3 all squared. Take the 25 to the other side. And now square root. We get x minus 3. Square root of 25 is 5. Square root of minus 1 is I. And there's a nice convenience place for the plus or minus. That then gives us that x is equal to 3 plus 5i or 3 minus 5i. And so the roots form a complex conjugate pair. Well, this result is in fact true for any polynomial equation with real coefficients. In other words, if we have a polynomial equation with real coefficients, then if 2 plus 3i is a root, then its conjugate 2 minus 3i is also a root. We can just write that straight down. As long as all the coefficients are real, then this must be true. We can prove this, but it's a little bit tricky to do just at the moment. So let's take an example working on this principle. Let's suppose that if 2 plus I is a root of the equation x to the 4 minus 6x cubed plus 10x squared plus 2x minus 15 equals 0, A, write down another root, B, factorize the expression over the real numbers, and C, solve the equation. Well, part A is nice and simple. We notice that all of the roots of the equation, all of the coefficients, all the coefficients are real numbers. Coefficients are the numbers multiplying. So that's 1, minus 6, 10, 2, and minus 5. All of those numbers are coefficients and they're all real. 2 plus I is a root. The coefficients are real. Therefore, another solution is the complex conjugate, which is just 2 minus I. So we now have two roots. We have 2 plus I as a root, and we have 2 minus I as a root. So we know that two factors, 2 plus I and 2 minus I, are roots. Therefore, x minus 2 plus I is a factor, and x minus 2 minus I is a factor. Well, let's multiply that out. We get x squared minus 2 plus I times x, minus 2 minus I will be plus 2 minus I in the brackets, times x plus 2 plus I, 2 minus I. And that, therefore, is x squared. The i's disappear. I get minus 4x. 2 plus I, 2 minus I is 2 squared minus I squared. That's 4 plus 1. That's 5. So we now know that this is a factor of the expression up here in the equation, right at the top of the page. To find any more factors, we need to divide x to the fourth minus 6x cubed plus 10x squared plus 2x minus 15. Divide that by the expression down here, x squared minus 4x plus 5. So 1 divided by the other, which is what we're going to do when we've moved the board. So a little bit of long division. We're starting off with x to the 4 minus 6x squared plus 6x cubed, 10x squared plus 2x minus 15, which is a little bit near the top of the board. So let's move it down just a bit. And we want to divide that by x squared minus 4x plus 5. Well, you are supposed to be further mathematicians, so this shouldn't present a problem. We need to multiply by x squared first, x to the 4 minus 4x cubed plus 5x squared. Subtract, and we will get minus 2x cubed plus 5x squared, and take down the rest. Minus 2x plus 2x minus 15. Now we need minus 2x to give us minus 2x cubed. Minus 2x times minus 4x is plus 8x squared. Minus 2x times 5 is minus 10x. Subtract. The 2x cubes disappear. We're left with minus 3x squared. 5 minus 8. 2 minus minus 10 is plus 12x. And take down the 15. X squared minus 3x squared, we need minus 3. That gives us minus 3x squared. Minus 3 times minus 4 is plus 12x. Minus 3 times 5 is minus 15. And we've finished. So, the expression that we started with, x to the 4 minus 6x cubed plus 10x squared plus 2x minus 15 is equal to x squared minus 4x plus 5 times x squared minus 2x minus 3, which is x squared minus 4x plus 5 We can't break that up any further just using real numbers as coefficients. And this is x minus 3, x plus 1. So that is the factorization of that expression, just using real numbers as coefficients. Part C was to solve the equation. Well, we know from the first part that 2 plus I and 2 minus I are both solutions. Let's make that look like a proper I. 2 plus I and 2 minus I are both solutions, and the equation above, or the factorizing above, shows us that 3 and minus 1 are solutions. This is all in your textbook, FP1, on pages 24 to 28.